Hello, everybody, and welcome to my final project. This is an exploration of Neptune, the eighth most distant planet in our solar system. Imagine a place so far from the sun that it takes light 4 hours just to arrive there. This is a planet where winds move faster than sound, where deep blue cloud cover layers of ice and gas, and where moons move in orbits that defy all expectations. Neptune is a planet that combines mystery, power, and beauty. Unlike the rocky worlds close to the sun, Neptune is an ice giant, which is a class of planets that reveal a very different side of our solar system. It's a world that challenges the way we discover planets, help confirm Newton's laws, and it continues to surprise scientists even up to this day. In this video, we'll explore the stunning structure of Neptune, dive deep into its weather systems, discover its fascinating moon Triton, possibly a captured object from the Kuiper Belt, and look at how physics helps us understand this super distant world, as well as share some really fun facts. For example, do you know that Triton, one of Neptune's moons, has geysers that shoot icy material into space? Or that Neptune might be raining diamonds deep in its interior? Unlike the other classical planets that have been known since ancient times, Neptune was not discovered through direct observation. Actually, it was found using math. In the early 1800s, astronomers noticed that Uranus was not following their predicted path based on the Newtonian physics. The French mathematician Urbain Le Verrier and a British mathematician John Couch Adams, they independently calculated the position of a hidden planet that could be disturbing Uranus's orbit. And then, on September 23rd, 1846, German astronomer Johann Galle pointed his telescope to the predicted location, and that was Neptune. This discovery was monumental. It was the first time in history that a planet had been discovered using mathematics, not rather in direct observation. This validated Newton's laws of gravitation on a cosmic scale. Now we're going to move into talking about some of Neptune's physical properties. Neptune is about 17 times the mass of Earth and nearly 4 times its diameter. Its radius is roughly 24,600 kilometers. Despite being smaller in diameter than Uranus, Neptune is more massive due to its denser internal composition. It has no solid surface. Instead, the atmosphere gradually transitions into an icy mantle composed of water, ammonia, and methane. Beneath that lies a rocky core that scientists believe is about the size of Earth. The pressure and temperature inside Neptune are so extreme, they might compress carbon into diamonds that rain through the mantle. And this is a phenomenon that's still being studied by planetary physicists. I'd love to visit. The outer atmosphere of Neptune is composed mostly of hydrogen and helium, with trace amounts of methane. Methane is what gives Neptune a deep blue color by absorbing red light and reflecting blue, which we learned about earlier this year. Neptune's atmosphere and weather. Neptune's atmosphere is among the most dynamic in the solar system. It features high-altitude clouds made of methane ice and large storm systems, including the infamous Great Dark Spot, and this was observed by Voyager 2 in 1989, a storm similar in scale to Jupiter's Great Red Spot, but temporary and very fast-moving. Wind speeds on Neptune are the fastest recorded in the solar system. They're up to 1,200 miles per hour. For context, that's 1.5 times the speed of sound. These extreme winds occur despite Neptune only receiving only about 1/900th the solar energy Earth receives. Scientists believe Neptune generates much of its heat internally, possibly from the slow contractions of its core and radioactive decay, and this would help drive those high-speed winds. A day in Neptune is about 16 Earth hours long. However, because Neptune isn't solid, different parts of the atmosphere rotate at different speeds. That's known as differential rotation, and the planet takes about 165 Earth years to orbit the sun. That means since its discovery in 1846, it's only completed one full orbit as of 2011. Neptune's moons. Triton. Triton is the largest of Neptune's moons and accounts for over 99% of the mass in Neptune's satellite system. It was discovered shortly after Neptune itself on October 10, 1846. Triton is thought to be a captured Kuiper Belt object due to its retrograde orbit. That means it moves in the opposite direction of Neptune's rotation, which is a behavior not seen in moons that form naturally around a planet. Triton is geologically active. It has volcanic plains, geysers, and even icy lava flows. Its surface is extremely cold, around negative 235 degrees Celsius, but it still has a thin atmosphere made mostly of nitrogen. Voyager 2's flyby in 1989 revealed geysers erupting from the surface, which suggests the moon may still have been experiencing internal heating and geological activity. Triton is locked in with synchronous rotation, meaning one side always faces Neptune, just like our moon does with Earth. Here are some other moons. Neptune has at least 14 other moons, with Triton being the largest. Others include Proteus, one of the darkest bodies in the solar system, and is irregular in its shape. Nereid, which has one of the most eccentric orbits in the solar system. Larissa, Despina, and Galatea, which are inner moons close to Neptune's rings. Halimede, Laomedea, and Sao, outer irregular moons, likely captured objects. And Hippocamp, a tiny moon possibly created from the debris after a comet impact on Proteus. The naming convention for Neptune's moons follows sea mythology. Most are named after Greek water deities, sea nymphs, Nereids, or children of Poseidon, which is the Greek equivalent of Neptune, which is how Neptune got its name as well. The physics behind Neptune. Neptune played a crucial role in validating Newtonian physics. The fact that it was discovered due to gravitational effects on Uranus' orbit is a direct application of Newton's law of universal gravitation. This shows that even objects millions of kilometers away exert measurable gravitational forces, and our understanding of physics could be applied on a planetary scale. Atmospheric dynamics. The incredibly high wind speeds of Neptune challenge our understanding of atmospheric dynamics. With winds and speeds exceeding the speed of sound on Earth, that indicates powerful heat and momentum transfer processes. Neptune radiates about 2.6 times more energy than it receives from the sun, likely from gravitational contraction. This excess energy drives convection currents in the atmosphere, resulting in complex weather systems. Thermodynamics and diamond rain. One of the most exotic predictions about Neptune is that it might experience diamond rain. Deep inside the planet, under pressures millions of times higher than the Earth's atmosphere, scientists hypothesize that methane molecules break apart and the carbon atoms bond to form diamonds that fall like hail through the icy layers. This was supported by laboratory experiments simulating these extreme conditions. Fun and interesting facts. So far, only one spacecraft has visited Neptune, NASA's Voyager 2 in 1989. It flew by at a distance of 4,950 kilometers and provided all our close-up images of the planet and its moons. Triton might crash? Triton is slowly spiraling inward towards Neptune. In about 3.6 billion years, it may either crash on Neptune or be torn apart to form a new ring system. Invisible. Despite being so massive, Neptune can't be seen without a telescope. This makes its discovery by math all the more impressive. Magnetic field tilt. Neptune's magnetic field is 47 degrees tilted from its rotational axis and significantly offset from the planet's center, suggesting a complex interior structure. Neptune is far more than a distant blue dot in the sky. It's a powerful, dynamic world that pushes the limits of what we understand about planetary physics, weather systems, and celestial mechanics. Its discovery revolutionized astronomy. Its moons tell stories of cosmic collisions and captured worlds, and its atmosphere is so wild, it puts Earth's hurricanes to shame. Though it lies at the edge of our planetary neighborhood, Neptune continues to be a key to unlocking the mysteries of our solar system. With future missions being proposed, such as Neptune orbiters or flybys, we may one day learn even more about its structure, moons, and the possibility of subsurface oceans or exotic materials. Thanks for watching!